Powder bed fusion technologies all use the same basic techniques to manufacture parts layer by layer. A heat source is focused on some powdered material on a build surface to selectively heat layers in the cross-sections of a part, according to a digital design. The heat source is most commonly a laser, but other methods, including some which use an electron beam or an infrared heater instead, are also available. The original powder bed fusion systems all used polymers, but newer systems can use ceramics, metals, or composites. Increasingly, powder bed systems are being used to directly manufacture end-use products rather than just prototypes. Here is an overview of a powder bed fusion process using a laser and polymer powder called polymer laser sintering. To start the manufacturing process, powder is spread across the build surface using a counter-rotating roller or a blade to ensure that the powder forms a layer of even thickness. The powder is maintained at a temperature just below either its glass transition temperature, which is when the plastic becomes soft, or its melting temperature. This is to minimize the amount of energy the laser needs to use and to prevent the manufactured part from warping due to large temperature differences in the material. The whole build chamber is sealed and filled with a protective gas to prevent the powder degrading. The laser beam is then focused on the powder and it is moved by two mirror galvanometers, one for the X and one for the Y axis, to trace a cross-section of the part. Mirror galvanometers are devices that can deflect light in different directions based on a variable input current. Once a cross-section has been traced onto the powder, the build platform moves down by the height of one layer and the next layer is scanned. This lowering and scanning process is repeated until the whole part has been manufactured. Once it has cooled and been taken out of the build chamber, any excess powder is removed. In polymer laser sintering, the word sintering specifically means liquid phase sintering. In liquid phase sintering, some of the powder melts and some stays solid. Fusion occurs between the melted particles and between the particles that are above their glass transition temperature but are still solid. Liquid phase sintering isn't just used for purely polymer powders. Often, systems use a mixture of a polymer binding material that has a low melting point and another powdered material, such as steel, to improve structural properties. The structural material doesn't get hot enough to sinter or melt as the laser passes over it, but the binder does. Sometimes, the powder particles themselves contain both the structural and binder material, either as a mixture or in the form of coated particles. Parts manufactured with a metal or ceramic structural material and a polymer binder often undergo some post-processing in a furnace to increase their density. First, the polymer binder is vaporized to make a brown part at a temperature that normally allows some of the structural material to sinter together. At this point, the part becomes quite porous, so another material, such as a metal with a lower melting point than the structural material, can be added to infiltrate the part. Another fusion method employed in some powder bed fusion systems is called full melting, which is often used to print metal parts. In full melting, the heat source penetrates much deeper than in the sintering process, re-melting previous layers of the object and creating dense parts. Unfortunately, parts are also more susceptible to what is known as part growth, which is a term used to describe the effect of excess particles sintering to the exterior of a manufactured part due to the high temperatures involved. Some powder bed fusion systems use an infrared heater and inkjet setup instead of a laser. The technique involves printing a cross-section of the part onto the powder using ink. Depending on the system, the ink either makes the powder absorb much more infrared energy or drastically reduces the absorptivity. When the infrared heater is turned on, only the powder particles that form a cross-section of the part absorb enough energy to sinter to each other. The inkjet method has the advantage of being line-wise rather than point-wise, meaning that instead of scanning each point individually, as with laser systems, full lines of ink can be applied in one go. The high temperatures involved in powder bed fusion change the properties of many materials, meaning that operators need to be cautious when recycling powders. polymer powders tend to be affected worst. Often, the longer a powder is exposed to the heat, the greater the average particle size becomes, as the particles begin to sinter together. This growth in average size means that the powder no longer behaves quite the same way. Part quality can deteriorate if this is not taken into consideration. A good way of dealing with the problem is to use a set ratio of recycled to new powder material.